Okay, so this is a worksheet where we're working on factoring polynomials. It's really an extension of what we did in 5.4. And the first section here, I think it's the first 6. Okay, they're all just factor by grouping. Okay, just standard factor by grouping problems. So things are going to change when we get down to 8. It's going to add one extra step when we get to, 7. And 7 through, I believe it's through 12. So it's like the first 2 chunks come in 6 problems. Okay, 6 of the same idea over and over again. This first section, we'll look at number 6. It's factor by grouping. And what we're going to do is we're going to come in and we're going to insert parentheses around the first 2 things and parentheses around the second 2 things. Keep in mind we really want to keep that negative sign there. Okay, we want to keep that sign there. That's, in this case, it's positive. Other problems, it might be negative. We always want to keep that sign there. Okay, then we want to ask, what do these 2 terms have in common? 24 and 28 both divide by 4, and m cubed and m squared both have a minimum of m squared. So that'll leave me with 24 divided by the 4 makes 6. And since I took m squared out of the m cubed, I should still have an m there. It's a plus, so I'm going to say plus. And 28 divided by 4 would make 7. And because I took both of the m's from the m squared, there should be no m with the 7. I come over here to the second parentheses and I say, what do they have in common? Well, it honestly looks like they don't have anything in common. The 6 and the 7 don't divide by the same thing, and they don't both have letters. So by default, I will take out a plus 1. Always take something, even if it's only a 1. A plus 1 isn't going to change anything in this parentheses. And so now I can take the outside pieces and make a parentheses, 4m squared plus 1. And I can times by the inside, which is 6m plus 7. We look at the squared term and we decide, can it be factored? Well, with a plus sign there, it's not going to factor. If it was a minus, it would encourage some further investigation. We'll look at an example of that here now with number 9. Let's change our color a little bit. There we go. Okay, so we look at question number 9. Same principle, same idea. We're going to split into the 2. Oh, shoot, I forgot. Why are these problems different? These problems are different because they have something in common that can be pulled out to begin with. 75 divides by a lot of different things. 5 is one of them, but 168 doesn't divide by 5, so that's out. 3 goes in 25 times. 3 would go into 120. 3 goes into 105, and 3 does go in to 169. But I'm going to have to figure out just how much. And notice they all have an n squared. Even if I can't pull a number, I might be able to pull a variable. So here I'm going to pull a 3n squared, and then I'm going to revisit the numbers. This should become a 25n cubed minus 120 divided by 3 is 40n squared. 105 divided by 3, 37, so plus 37n. And then the 168 divided by 3 is 56, so minus 56. And because I took n squared out, there'd be no n's there. Now, I still get to go back and insert parentheses around the first 2 objects and parentheses around the second 2 objects. So 7 through 12 are going to require some sort of factor out before you start. You want to take the biggest possible thing. So this 25n cubed and 40n squared both divide by 5n squared. And that, if I take the 5 out of 25, that makes 5. N squared out of n cubed makes n, minus 40 divided by 5 is 8, and I took the n squared. Okay, over here, what do these 2 have in common? Ooh, I made a mistake. One of my numbers is not divided correctly, because that is not going to work for me. Let's try and check my math here. I think that 37 is a little funny. 105 divided by 3 is 35. That's a mistake. So let's make that a 35. There we go. Now both of those are going to divide by 7. 56 and 35 both divide by 7. So I'll bring out a positive 7. That'll leave me with 5n minus 8. Now all of that still has, let's not forget, we've got a 3n squared outside of all of that. Well, to finally clear up my answer, I'm going to have 3n squared and 2 parentheses. One of them has the outside stuff, 5n squared plus 7, and the other has the inside, 5n minus 8. Looking at your n squared term, if it's got a plus with it, plus a number, it can't be factored further, so we are done. Okay, let's take a look down at one more problem. This will be our last type, the last style. The last 8 questions, 13 through 20, are all similar. They are what is called quadratic form. The exponent of the first term is twice as big as the exponent of the second term, and there are no x's in the last term. So this behaves like x squared plus 8x minus 9. If you could factor this one in red, then you should be able to factor this one that was printed for the problem. So we'll just kind of think our way through this. X squared splits as x and x. How do you split a 9 so that when you minus you get 8? That'd be 9 and 1. And then because the 9 is negative, the signs are different. To get a positive 8, I need a plus 9 minus 1. Now the difference between this and this problem that we originally had is that instead of splitting it as x and x, we're going to split as x squared and x squared. And then that will give us a plus 9 and a minus 1. Now earlier I've said it a couple of times, we always look at our x squareds and see, does it divide, does it have that subtraction and perfect square? So this is x squared plus 9. I can't split a plus there, but x squared minus 1. If this has a square root, then we can keep going. So I do know the square root of 1 is 1, which means the x squared plus 9 stays like it is, but the x squared minus 1 can be factored as a difference of squares. X and x plus 1 minus 1. And that is my fully factored problem. All right, guys. Hopefully you're able to get some help. If you need it, shoot me an email or come and see me before or after school, and we'll try to get you the help that you need. But hopefully this will help you, and good luck. We'll see you in class.